Alright, welcome to 7.2, more on constructions. Last time we did rhombuses and squares. This time we're going to talk about triangles and hexagons. Super fun. Okay, like a rhombus, an equilateral triangle has three congruent sides. If you didn't know that, now you do. Show and describe how you might locate the third vertex point on an equilateral triangle, given ST is one of the sides of the equilateral triangle. Well, then the sides of ST must be all the sides of the triangle, right? So, kind of like a rhombus, how do you know something is the same length? Again, we're not going to use these guys. These don't exist in our Egyptian world here. Neither do these guys, fun fact. So how do we know it's the same length? We treat this as a radii. Same length. The only thing we are guaranteed to be the same length is a radius. All the radii have to be the same length. So let's create a radii. A radius, pardon me. A radii. Okay, where are you? There it is. All right, so it looks like I got this dot here. Looks like about, well, can we get closer to the other one? Nope. That's about close as we can get. So, yeah. 1, 2, 3, 4, 5, 6, 7, 8 dots in on the bottom side. Now, if I create a circle out of that, again, we're going to draw all over the instructions here. It's now become the radius of that circle, right? See the circle, there's the radius. So any point over here would also be the same length. But here's the trick, is if I just pick a point at random, I'm not guaranteed that these two are. In our rhombus, we saw that A and C were not the same length apart. And so we don't want to just choose a point at random. Instead, we kind of want to do a perpendicular idea. The eighth dot. Let's go over here again. Let's create another radii. Let's create a different circle, kind of a backward circle, but we get that same radii. This intersection point is now equal distance from S and from T, that same distance of ST. Let's label it, I don't know, R. Q, R, S, T, U, V. Connect the dots. Carefully you don't do what I just did and miss S completely. Okay, and then we go over here, and because all radii are the same, we know it is an equilateral triangle. Fabulous. Okay, there's equilateral triangle for you. Parallelogram. Construct a parallelogram. We need to be able to construct a parallel line, something that is parallel. Well, how can I guarantee it's parallel? Okay, so how are we going to create a parallelogram? Well, we need a parallel line, right? We need the same line somewhere else. The only thing we got same length. Sorry, I had to erase a couple things. Here's the same length here. So here's the length of AB. Let's just check that out. What is the length of AB? There's A, there's B. We're looking at 1, 2, 3, 4, 5, 6 dots on the bottom. If I now take that over to C and draw a decently sized circle, I know that somewhere there's going to be a radius. All of these are the same length, right? Are they parallel? Absolutely not. We can tell those are not parallel. But somewhere in there is a parallel line. At least we have the same length. Let's now do the same idea from B to C. So let's measure out BC. There we go. Looking at the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to go up to A and kind of mimic that length, right? You gotta hold that A tight. You gotta hold that A point tight. Okay, so what I've done here is now I've created an intersection point, and you can see that is where we get our parallelogram. So I don't know, we'll label it D. Just make it nice and OCD friendly. This line definitely parallel to that line. I'm sorry, it's definitely the same size as that line. And this line, definitely the same size as that line. Here's the thing, I can even say they're more than just the same size, they're the same angle. This angle here has now been copied right here. I've basically taken this picture and reflected it over there. If those are the same angle, I can guarantee you those are the same distance apart. And therefore, these two will be parallel, and these two will be parallel. Cool beans. Sweet, so that's how we create a parallelogram. We basically just copy and paste both sides. Alrighty, moving along. This one, next one's one of my favorites. Constructing a hexagon inscribed in a circle. Now what the crap does that word mean right there? That's going to be a big word. Inscribed. As you can guess, it does mean inside. Inside a circle. So if you ever see something inscribed in a something, then that means inside. The circumscribed has its center, but then it's kind of like rotated around. It's really weird. But so inscribed, everything is in the circle. So kind of let's explore this a little bit. We might begin constructing a hexagon by noticing that a hexagon can be decomposed into 6 congruent equilateral triangles formed by 3 lines of symmetry. Interesting. This shape here, lots of symmetry, right? If we turn it around, we get the same shape. This shape, not so much with the symmetry, right? If I turn this is now SRT. You can see that. I turn this guy, he's gonna look like that. He's not gonna be the same going upside down, right? And so lines of symmetry, kind of that idea that we can turn it, we can rotate it whichever way we want, and we're gonna get the same shape. Now obviously I can't take a triangle, draw it this way and get the same thing, right? But then we know that's the same shape. We just want this kind of like, I can move the points and get the same shape. So this guy's gonna have 3. That doesn't mean every degree number he's gonna get one, right? This takes a full 60-degree turn, nope, 120-degree turn, pardon me, before it gets to the next shape. I don't need to go all the way around. He can actually get the same shape if we flip it 180, right? So he does have rotational symmetry as well, lines of symmetry, and we can flip it around. Let's look at the lines of symmetry here. Well, let's first start with a circle. Mark the center, can't forget that. I personally like that one because it's just easy to use. I just used the last dot of the gray part. You don't have to use that one. Let's kind of eyeball a hexagon. We're not sure this is going to be a regular hexagon yet, right? We are shooting for regular. Regular means all the same size, right? Like, so an equilateral is an equilateral triangle is a regular triangle. We're going to try and do a hexagon guy. Here's like one line. This kind of looks kind of like that. Yeah, I'm not 100% sure, but if I connect all these dots now, or I'm sorry, all these intersection points to the circle, I'd get a hexagon. This is kind of the idea we're going to use to create a regular one, but you can tell that one's much bigger than that one, right? So this is not the best method for a regular hexagon. It does, create a hexagon though. Okay, so here is a hexagon. We're going to pretend it's regular. How much, what is the center of the circle that would circumscribe the hexagon? Forget that question. How much would I have to turn this to get the same picture? Well, if I turn it all the way around, I get the same picture, right? If I go all the way around, that's 360 degrees. But I don't need to do that here, right? Without points and stuff, if I turn this just a minimum of 1 triangle, then I would be able to do that. Well, there are I would get the same picture. There are 1, 2, 3, 4, 5, 6 triangles. So I only need to turn it about 60 degrees, which is great because I don't want to have to turn it more than I need to, right? The center of the circle kind of also acts as the center of the hexagon. And that's how we get, the inscribed hexagon. That's how I know, inscribed hexagon. I know it's in the center of the circle. Okay, that kind of answers these 2 questions. Fun fact. Now let's actually try to create a real one. A real, actually regular hexagon. There are 2 ways to do this. 2 ways to do this. There is an easy way, but requires a few more strokes of your pencil. There is a simple way, there is a harder way, but requires that you remember something about another shape. So we're going to do kind of the multi-stroke one, just because it seems to go well with what we just drew. So the first option, you saw that I kind of just drew a bunch of lines and then connected them. I didn't know anything about these lines though. These lines were not the same distance apart. The problem here was that this did not equal that, right? This was not the same as that. We can see that this is much tinier, this is much larger. And when I say much, I do mean like a couple degrees, but it was enough. It was enough that these ended up not being the same length. So we're going to fix that problem. How do we do same length? Oh yeah, radii. So here's our circle here. They've been just nice enough to give us one. We can find that it is about the third circle big, right? Third circle big. You can draw the same one. I'm gonna move my paper down a little bit. Because of that, if I want all of my hexagon lengths to, or my side lengths to be the same, I'm gonna use the same one. I'm just gonna move not the edge of the circle, but the center, again with this moving of the center idea. If I create another circle here, okay, there's one, then I get 2 of my points in the hexagon. Yeah, clearly that's not going to be enough to fit 6 in there, but I know that they're both equal distance from here. And I get 2 sides of a triangle, kind of. Not going to connect this third side, that's not going to help me. Instead, what I'm going to do is I'm going to take that third point again, this one, the bottom one, and I'm going to go to one of those intersection points. And I'm going to draw another circle. Maybe not the whole circle this time. I'm just after those intersection points. And I get 2 more. Those will definitely be the same distance apart, okay? And then we're just gonna kind of keep going around the circle. So my third point, I'm gonna create this guy, 2 more. Notice, since these are now radii of the same size circle, these 2 guys ended up hitting this guy again. Not really after him though. Here's another one. I need 1 more. That third circle there, where did it go? Nope. There it is. And yeah, due to human error, I was a little bit off, but it's still pretty good. Okay, I've gone around the whole circle. I could draw 1 more just to prove to you that I'm not going to get any more points out of this. Fun little fact. I end up hitting back that same circle. So I get this cute little star shape, flower shape, whatever you want to call it. But what I really get is 6 sides that are all the same length. So in case you didn't catch that, basically what I did was I took the size of the circle and I went around the circle. I kind of took it and I just went circle, 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 circle. And I got my hexagon. And there's the first method. Okay. The second method, like I said, it does require a knowing of another shape. The shape is equilateral triangle, so I'm going to show you that one a little later, if at all. But really, this is kind of the best option, in my opinion. Alrighty, that's how we draw a regular circle, a regular hexagon inside in a circle. Now let's modify that, see if we can construct an equilateral triangle. Also 2 methods. Equilateral triangle, method number 1. You only connect 3 of the dots. 1, 2, 3. Ta-da! Super easy if you already have a hexagon. You also get 2 out of them, right? You can do that one. And those are equal in distance as well because, again, they're created by the same circle. So this was when we had, we had the 2 here, and I'm like, don't connect that one. If you wanted a triangle, you'd connect those ones, okay? So that's method number 1. You create a hexagon, you don't connect all the dots. However, that's a lot of work if you only want a triangle, right? If I only want a triangle, there is a second method. There's actually 2 more methods, but this one is eons faster. Start with a diameter across the circle. Oops. Actual diameter that goes through the center, which would be nice. Okay. I now have a diameter. Remember, diameter is 2 radii, so I know these 2 are the same. Not that that's super important. We'll label it, I don't know, A and B. Now what I'm going to do is from that point A, instead of creating a radii to the center of the circle, I'm going to measure from A to B. Instead, I get 2 radii, which that's what this length is, 2 radii. And I'm going to, oops, nope, just kidding. Nope, just kidding, not from A to B. I'm going to measure from A to the center, and then I'm going to create another one and find 2 intersection points. Sorry about that. So, diameter, and then also one of these circles. What I have found is triangle DCB. I think you get kind of like a Hunger Games Mockingjay symbol out of it, but really what we're after is triangle ABCDB. He is equilateral. All right, cool. These are the kind of the two ways to create an equilateral triangle. Hexagon, you create an equilateral triangle, and then you just use this kind of idea to make two more points here. You kind of just go from A over here and B over there, and you have your other points. So it's basically this method over again, just you kind of cut out a few of the circles you need. That's why this one's kind of best. But alrighty, last part. Describe how you might construct a square inside a circle? So I think the best way to describe it is to just do it, especially since this is a video. So let's go ahead and make a circle. Notice how center was kind of key in both of these, so let's also put a center down. Okay, I know I made it a considerable smaller, but it's fine. Now, squares are kind of unique, right? Squares, we need more than just the same length. We need that 90 degree again. So what are we going to do? Start with a diameter. Oh, jeez. One of these days I will remember to move my compass back a bit so that it will actually go through the center. All right, now I need a perpendicular line there, and I will have my square, right? So how am I going to get a perpendicular line? I'm basically going to pretend this circle doesn't exist, and I'm just going to do the same thing we did to create a square in the last one. I'm going to make the fish. Notice I'm not super keen on getting the whole fish. And yeah, my fish didn't exactly line up with the edge of my circle. Not my point. Not what I was after. I just want a line that will cut this in half. And I was pretty close. Now I can go through and say, oh yeah, where that line intersects the circle, I get my square. So basically what I get out of this is I basically drew a diameter and I cut it in half across the circle, right? It was convenient that when I cut that segment, that diameter in half, it went through the center. Because, whoops, a diameter, oh my gosh, okay, there we go. A diameter is 2 radii, so I had a split anyway. Then when I turned that, I get 2 more radii. What I get are my 90 degrees, and same size. And I get a square. Cool, so diameter, cut it in half. Triangle, diameter, circle. Hexagon, circle, 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 circle. Alrighty, that's a lot of shapes. And then once again, I went fast intentionally so that if you needed to, you can go back to a certain part of the video, or you could ask the sub questions, or you could, if you totally got it, just go to homework time. If you do have any questions, please ask the sub now.